Hello everyone, this presentation is on herbivory, turnover, and decomposition rates in aquatic and terrestrial ecosystems. When talking about the terrestrial versus aquatic ecosystems, what's important to note is that the net primary production is the same. When looking at terrestrial ecosystems, we can see that there are a lot of autotrophs and little consumers. But when looking at aquatic, this is actually inversed. There are a lot more consumers than there are autotrophs. But why are there more autotrophs in a terrestrial system versus an aquatic? Well, that's because the herbivory, turnover, and the decomposition rates are different. But before getting to how they're different, we need to know why. And that's mainly because water supports plant tissues and air does not. So the terrestrial plants that are on the land, they require more structural compounds to keep them together. And particularly, they use cellulose and lignin. Cellulose is about 33% of a plant's biomass, and lignin can be anywhere from 17 to 35% of a plant biomass. And these components are very rich in carbon, so they're hard to break down. And because of the amount of this carbon, these plants are less nutritious. And this leads us into why herbivory, turnover, and decomposition are very different between the aquatic and terrestrial ecosystems. Herbivory is different in aquatic and terrestrial ecosystems because of consumers. Consumers choose what they eat, and well, they eat what is more nutritious for them. And aquatic plants, because of the lesser amount of carbon, are more nutritious, and hence herbivory is high, where terrestrial plants, which are more rich in carbon, has low herbivory. And actually, the percentage of production that is eaten by herbivores is higher than what is in terrestrial communities. And in fact, because most aquatic plants are small, there's more to eat. Considering aquatic plants are eaten more, how haven't they just disappeared? Well, that's due to turnover rates. And turnover rates is basically quantifying the harvest and then replacement rates of individuals in a community. And so in this case, be aquatic plants. And in particularly because of the small size, the lack of structural tissues, and the defenses that aquatic plants have, that means that primary producers achieve way faster growth rates than they do in terrestrial ecosystems. Now that I've talked about herbivory and turnover rates, there's decomposition. Well, decomposition is the process by which detrivores break down detritus to obtain energy and nutrients. So basically, this is just the release of energy and nutrients as a simple, soluble organic and inorganic compounds that can be taken up by other organisms and used. When decomposers are breaking down the detritus, the same food quality differences apply as it did in herbivory. So there's less detritus in aquatic systems versus terrestrial because it's more nutritious. So we can see that in terrestrial systems, there is a lot more detritus. So the decomposition is much faster in aquatic systems. As an overview to the aquatic versus terrestrial ecosystems, we can see that despite the net primary production is the same, that the herbivory, turnover, and decomposition rates are higher in aquatic systems compared to the terrestrial. And this is mainly due to the support that water gives aquatic plants. Because the water supports the plants, they don't need much structural components like cellulose and lignin. So this makes them more nutritious because they're more rich in nutrients like nitrogen and phosphorus. So this increases herbivory because the herbivores want to eat something that is more energetically favorable. And because they're being eaten a lot, they're more nutritious, and they're small, they can grow better in turnover. And this also means that there's less plant tissue needed to be decomposed. But even then, the decomposers want to eat these more because they're more nutritious. This is the end of my presentation and my last video. Thank you for watching.